www.apidum.lk today.
You have to.
Hello and a very good evening to all of you once again. Welcome to this third episode of our webinar series on the topic of Internet of Things. This is an online short course offered to you by the Asia Pacific Institute of Digital Marketing, and our knowledge partner for this program is Zone 24/7. Now, we have had the first two episodes of this training series or the short course last Monday and Wednesday, and we have discussed like what is IoT, and we had an introduction to IoT, and then on the second day we went a little deeper and we discussed about like IoT architecture and some use case scenarios. And today in the third episode, we are going to discuss about the challenges of support engineers that work from home. That's going to be the main topic for the day in this last episode. And it's going to be the same resource panel who will be joining us shortly: Heshan, Asankar, Isuru, and Ishrat. And like you did last two episodes, keep your questions coming in as Q&As into the Q&A box while our main presenters are addressing the topic for the day. Other resource partners, they'll be actually answering your questions behind the scene directly through the Q&A box. So keep your questions coming in. And one more thing, I told you last time in the second episode that you are going to earn a certificate of participation for completing this course, all 3 episodes from Monday to Wednesday to Friday, connecting live. Now, if you are one of those people who connected to all 3 episodes of this series of webinars, you are going to get a virtual certificate from Apidum, and you will be contacted by our Apidum team, Apidum staff, probably by next month, Monday, Tuesday, Wednesday. Within the course of the next week, you will get a word from our team. All right, so those are the announcement. Now with that, let me invite our panel today, Heshan, Ishrat, and Asankar. I invite you to come online. Yeah.
Hi, everyone.
Right, so over to you guys, starting from this point.
Sure, Amita. So let me quickly share my screen. We can get started. Okay, trust everyone can see my screen. Okay, great. Right, so good evening, everyone again. So as Amita mentioned, over the past couple of sessions, we have introduced you to the Internet of Things, and we dug a little bit deeper on the second day where we discussed architecture. We took a sample use case and spoke about how that would be IoT enabled, what are the components, what is the software associated with it. And we also spoke about the challenges that you face with supporting an IoT operation, that keeping it alive is not easy. And Ishrat covered that on the second day. And today, we're going to take that a bit further. We'll be talking about tech support in general and what we refer to as support technology or support tech, where in order for you to support an IT operation, especially in a work from home situation, what you need to think about and what should be a part of those tools that you choose to use for your tech support. And of course, we'll be touching in on how this impacts to the IoT as well, but it can be looked at from a broader scope as well in terms of general tech support, right? So today, the topic is, I will be discussing a tech support structure, typical tech support structures, and a couple of common mistakes that are made by decision makers in selecting the right support technology. Then afterwards, similar to last time, Ishrat is going to draw on his experience and talk about how this work from home scenario has impacted him and his teams, and what he foresees as requirements for us to be able to support these work from home scenarios, especially for our tech support team going forward, right? And how we need to think about tuning our tools. So let's jump straight into it. Right, so if you look at a typical support structure, before we talk about the support structure, we'll talk about how a solution or technology comes into being, right? So if you start from the bottom, of course, it's the engineering, the implementation teams that actually develop the technology. And these are the people with the most intimate knowledge about the technology. Once you're done, then you've got your DevOps or your deployment or your infrastructure teams that will actually do the deployment at the client end, or if it's a cloud, do a cloud deployment to actually let it go live or go into production, as we say. And then on, you've got your support engineers and your help desk support teams that will be involved in responding to customer queries, responding to issues that customers face. And typically it will be, let me get my pointer here. So typically it will be the end user itself or the vendor management team of that company that interfaces with the help desk support system. And sometimes when resolving these issues, if the end user or the vendor management team, who is usually not technical, cannot answer this, then we need to resort to getting more information. And Ishrat will cover this in greater detail and why this is a problem. And you need to resort to contacting support teams. And when you need additional information from support teams, they need to look at IT security and get their approval before providing information. And they are the ones who will basically decide when and whether you will actually get access to the end devices, servers, software, as well as sometimes third-party vendors where you depend on third-party systems and products to actually realize a use case. And sometimes you even have to resort to connecting or contacting the third-party vendor as well. And there are a lot of problems and a lot of disagreements that can take place when that happens. So what we refer to as a support structure, we commonly refer to them in these four terms. And of course, this varies. Sometimes you might end up at only L1 and L2, sometimes only L1, sometimes you might go into more than L4 as well. So what we look at is that common terminology is L1, L2, L3, L4, short for level 1, level 2, level 3, and level 4. So your first point of response is your help desk team. The help desk team typically goes through a script. They've been trained on how to ask a specific set of questions, and if the questions and the responses from the customer conform to that particular structure, they will be able to solve problems. And if not, then they will open up a ticket. And I'm pretty sure we've all gone through this in trying to get in touch with the contact and the support teams of our services that, for example, various TV providers, telco providers, when we want a problem solved, if the initial person can't solve it, they open up a ticket and you have to wait for some time for them to get back to you. And if they can't get back to you, if the help desk team can't immediately solve the problem, then they engage a level 2 team. So a level 2 team will try to solve some of these problems. And if they also can't solve it, then this will trickle down to level 3 and level 4, right? So in a nutshell, I mean, your L1 to L4 support team, we refer to as a vendor support realm. Vendor is you, if you are the provider of the technology. And of course, the client is the consumer, and that's the client realm. So if you consider these 4 support levels, there are some key differences about them, right? One is usually the cost per head of a support engineer going from L1 to L4 increases, right? The reason for that is usually the expertise of those resources or the type of person at L4 is much higher compared to that of an L1 respondent. So as a result of that, your tech expertise level is usually lower at L1 and usually a lot higher when it goes down and then it eventually reaches L4. So the L4 guys have very intimate knowledge about the system that they have deployed. And if nobody from L1, L2, L3 can solve it, then of course it falls on the guys who created the technology to try and solve the problem. So as you can see, there is a problem where due to the higher tech expertise of the L4 teams and the L3 teams, and as you go down, you need to maintain your support structure in a certain way. So this is in the form of a reverse pyramid, right? So your aim should always be to reduce the number of people you need at L4, especially when it comes to supporting or to responding to support requests. So your aim should always be to reduce the number of tickets that trickle down to these levels, which will eventually result in the number of resources at these lower levels being reduced. So, for example, your L1 and L2, all three, and as Ishrat may discuss, he will even discuss an L0, a virtual L0, virtual support level, which should hopefully take care of a large majority of tickets rather than human even having to get into it, right? And humans get into it if it becomes so complex that it goes beyond the standard mode of operation, right? So this should be our aim because that's how you will have a cost-efficient operation of a support structure, right? Now, moving on to the second part of what I am going to discuss are the key points to remember when it comes to support tech selection. Support tech selection, meaning the technology that we use to support an operation. So I've used a couple of abbreviations here. UEMs are not RMTs. So for some of you, it may be cryptic. What do I mean? UEMs are a common term which is used for unified endpoint management. Right? And you find a lot of unified endpoint management tools out there. And I mean, there are some dominant players in the market. And I mean, you just Google this term, you'll find the dominant players popping up. Unified endpoint management is not RMT is a key thing to remember because unified endpoint management, its focus is on breadth in terms of coverage of technology and not depth. What I mean by that is their focus is on providing a unified manner in which you can control your Windows devices, your Linux devices, your Android devices, your iOS devices, you name it. So they want to cover a massive breadth. But the functionality that they provide would be generic and at the same time, it would be standardized. And what that means is it does not really cater to very specific needs of organizations. And we've seen how when organizations have treated UEM tools as RMT tools, have then gone to them saying, hey, we need some modifications done. This is not really suiting our troubleshooting operation. And of course, they're willing to do it, but they would charge you an arm and a leg. And that is fair enough. That is not what their focus is, right? And if you take RMT tools, and why you should need, or the focus of RMT tools, so RMT is short for remote monitoring and troubleshooting. The focus here is it should provide in-depth insight into when something goes wrong. The RMT tool should tell your teams right up to L4 level what's gone wrong so that they can hopefully come up with the root cause. And the advanced RMT tools, which are needed for our current use case as well as when we head into the future, especially in terms of IoT, should do the root cause analysis on its own and tell you, hey, this is where the problem is, and even go to the extent of prioritizing these so that it tells you, hey, kind of like the 80-20 rule, where 80% of your problems are relying on these two root causes that I've identified, address them first, then move on to the other one. So these kind of intelligence is something that RMT tools should provide in the future. And apart from that, it should be very granular, apart from the monitoring and insight, very granular and case or use case specific in terms of the control that it provides to the organization or to a specific organization. What I mean by that is, depending on the kind of software that you deploy, the kind of peripherals that you attach on your end devices, how you need to troubleshoot them will vary. Some scenarios may require you to actually go and restart the firmware of a device when a particular problem occurs. And if you do not have that level of control to actually do that remotely, that means you're going to spend maybe half an hour, 45 minutes trying to get a non-tech savvy person at the edge, at the site of the problem, trying to solve it for you. Or you have to deploy somebody to actually physically visit the location, which is going to be extremely expensive. So you need to understand that unified endpoint management tools are not remote monitoring and troubleshooting tools. Hence, you should not burden your support staff to purely depend on UEM tools to carry out their RMT. And Ishrat will discuss these in detail, right? The second aspect is, even when you choose an RMT tool, keep in mind that one size does not fit all. There are plenty of RMT tools out there with standard capabilities and a lot of capabilities. But especially if you look at IoT with the type of heterogeneity that you hit with the types of devices which we discussed last time, you're going to end up with a lot of unique use cases. And usually IoT devices or solutions, each solution or each device might come with its own monitoring and troubleshooting system. But as Ishrat will discuss, having multiple systems is not a fun thing, right? And Ishrat will discuss that in detail. And as a result, whatever generic RMT tool that you use, make sure that they are open to customization and they have a right model and pricing to offer you for that at the onset, without making sure that you get caught in a trap or you get locked down to that vendor. And at the same time, that when the need arises, they would charge you an arm and a leg to actually facilitate the changes that you have requested. Right? So these are the two very, not so spoken about mistakes that people make in selecting the technology. And at the end, they would look at why their support teams are not meeting SLAs. And the support teams are actually helpless because of the inefficiencies that have resulted from the tech selection. So that being said, I'd like to hand over to Ishrat to discuss the woes of tech support from home. Ishrat, over to you.
Thanks, Ishan. Yeah, so let me take up the slide. Okay, can everyone see my screen? Yeah? Right, okay. So thanks, Ashan, for that intro. In my set of slides, basically we're going to talk about like how tech support generally works and what are the problems encountered when you shift these operations to work from home. Generally, large organizations in the sectors of logistics, transport, warehouses, etc., they tend to use technology such as wearable computers and handheld smart devices for their day-to-day operations. So it's very important that these devices are properly functioning, even during a pandemic situation. So that's where you have to have your support teams who are compelled to work from home, just to ensure that the smooth flow of operations continue to take place at those very essential service areas. The typical methods used by tech support personnel when it comes into handling issues, one is there is a significant amount of back and forth communication with the customers. So in an attempt to obtain the details, before I can't get to that, so we have the client who has to, or the customer who has to actually raise the issue on their issue portal, and then one of the support personnel will get in touch with the client and extract the necessary details into the information. So then these details are, depending on their complexity, are escalated to level 2 or level 3 support personnel, and then support personnel gets in touch with the client and executes the remedial steps. So now, so here so basically the success or the number of iterations of back and forth communication is directly proportional to the tech savviness of the client. So the more technical savvy the client would be, the more details he will be able to transport to the technical to the support team to handle the issue. But whatever it is, at the end of the day, the client has to take part in actually deploying the solution, which is going to cause severe client dissatisfaction because he is part of the solution itself. So, so when it comes into communicating and identifying how to solve a problem among tech support individuals, generally what people tend to do is they have quick discussions among peers when it comes into resolving these issues. So majority of these communication is very non-verbal, right? So people tend to share the screen, share whatever images that you may have, exchange ideas over the desk, and so basically there's like statistics have shown that 93% of all the communication that you do is non-verbal. That's related to like hand gestures, the tone of your voice, your body movements, and only 7% is actual content. And sorry about that. So another method that is used by technical support personnel is a very sledgehammer-based approach into extracting the details of an issue. Most of them tend to use very bandwidth-intensive approaches like remote desktop to get an idea as to what this problem is. And due to slowness of the network, the delays that causes because of the slowness of the network will actually require more time to obtain that information. As a result, it will eat into your SLAs. So so sledgehammer approaches like remote desktop and device reboots are one of the primary, majority of the time, that's what the technical team tend to do. So, and also opening ports on the internet for these sort of actions to be carried out by support personnel itself is a risk to your solution itself. So let's talk about the challenges that when it comes into providing IoT related support. So we discussed thoroughly about these items during our last session. I'll quickly skim through here. So the actual IoT's value proposition relies on connecting different types of device types and addressing the problem of the client. So in last time we took an example where we had an autonomous robot which extracted the RFID in merchandise details and then transmitted into the client's database, and from there it went onto the electronic shelf labels and also made it available on the kiosks. So when you have several solutions, several device types, I'll take it as device types, connected and handling a problem, you eventually end up with more and more remote monitoring tools which are required to manage those solutions. So each vendor will have its own remote monitoring tool. So then definitely the number of tools that the support team has to use tend to increase as a result. Repetition of the same issue. We spoke about this where it causes backlog and time which could have been spent on addressing a more important issue is wasted because you are addressing these repetitive issues which are appearing. So to carry out certain tasks like device restarts or service restarts, connecting the configuring the connections rather, sorry, require an elevated level of support because of the technical gap between support teams. When there are multiple system owners, Like Heshan mentioned earlier, it's difficult when it comes into obtaining the relevant information that we want to identify an issue or even to deploy a solution. It requires a lot of approvals from different levels from the client. Multiple points of failure. So although individual subsystems or individual solutions may be working as expected, but the connected solution may not be working. So for an example, the RFID robot ran, extracted the details, but some of the electronic shelf labels have not got updated with their promotions. Why is that? So the electronic shelf labels will be working individually, but the connected solution is not. And finally, like Mishan mentioned previously, certain UEM tools do not facilitate troubleshooting. They mainly cover like firmware updates and security lockdowns, and do not address the troubleshooting part of it. So let's move forward. So having said that, the challenges faced when it comes into providing IoT support, how it tends to get aggravated when you start to work from home. So the image that you see is an actual scenario from NASA, where they are managing the Curiosity rover's movements from their home. So there was a big challenge involved in moving all of the equipment from the JPL facility over to their homes. So it was a very complex operation. So one of the problems that we tend to encounter is the infrastructure related, the inefficiencies related to the infrastructure that we have. So, so for an example, let's take the network connectivity. It's unreliable. The Wi-Fi signals are not strong enough everywhere in the house. Internet speeds are generally lower than what you get at work. And one of the biggest problems we all face is the monthly data caps. Towards the end of the month, we run out of data. So these sort of unreliable network connectivities actually becomes very frustrating to the team, and also becomes frustrating to the client, because you're trying to have a decent conversation with him, but unfortunately due to the network lagness, you can't even communicate your resolution, or try to identify what his problem is. Itself becomes a big task. Then we have cramped screens. Yeah, so at office, we are very used to have multiple screens, each screen running its individual solution. So it helps us to understand how problems propagate from A to B. But when you start to work from home, you end up with your laptop screen only. So it becomes very difficult to navigate among multiple screens. You need to keep on toggling around. So what happens to that? You end up taking a lot more effort trying to identify a problem, and it eats into the time. Extra time is needed, and eventually it boils down to your SLAs. So we have then communication related inefficiencies. So background noise, you have, I don't have to give examples, I mean, squirrels, dogs barking, vendors screaming their guts off from the road. So, can actually put off certain teams when they're coming to, when they're meeting up together. Then we have difficulties in coordinating a response. So it's very challenging to communicate among teams without visual aids. Like I mentioned earlier, verbally communication, the actual content may be only at 7% of the actual words is only 7% of your communication, but 93% of it revolves around your facial gestures, your body language, your tone, the movement of your hands. So, so in order to communicate that correct point needs an extra effort. And normally another thing is like, when it comes into discussing problems, we just normally have a casual chat, share the logs, discuss over the desk and come to a common agreement. But now you tend to need to use video conferencing calls, audio conferencing calls, and also keep track of the many chat groups that you are part of, and getting everyone's agreement before you carry out an action also becomes increasingly difficult. Furthermore, we have distractions. So it like, TVs, movies running on, games. So at the home environment, you have all of these available. So you tend to sometimes relax a bit. And then because of that relaxation, you might end up missing out on certain critical notifications, which could be detrimental to the entire solution itself. So then we have tools related inefficiencies. So some tools you need to like continuously keep on monitoring the sensorial data. So I can take an example. When it came into the managing the robotics operation, there was a frequent sensor related information is populated. So sensor information related to the wheel movement, to inability to navigate through certain areas because of the restriction of the aisle width. So those are sort of alerts and information that continuously keep on gets fired onto our end. So if there's a way of providing an automated solution to de-escalate or do a remedial steps for that, so those sort of things are very important when it comes into tools related to increase the tool's efficiency. We will get into that a bit more at the late of the day. So how the correct IoT tool can actually support all of this is very important since we are working from home. So let's take how a tool, the correct IoT tool, a support tool could help with the infrastructure related inefficiencies. So, sorry. So unreliable and limited network connectivity. So we can have, if you have a tool which allows you to obtain a snapshot of the device as of now, then that will communicate a large amount of information readily to your support teams. So these reduce the number of back and forth communications you need to carry out with your client. And also it helps you to avoid the use of very bandwidth intensive operations like remote desktop, Windows remote desktop or TeamViewer or any desk sort of tools in order to obtain that information that you want for your initial analysis. So if the tool can give you a snapshot of the device, hey, this is what this is what is happening as of now, that's a lot of valuable information for your team. Like I have mentioned several times before, auto escalation of issues. So over here, what I'm trying to mean is auto escalation of issues means, so it reduces the team, depending on the severity of the issue, if you can have those relevant issue notifications communicated to that relevant elevated teams, then it reduces the amount of time required in conferencing. So that helps a lot. When it comes into cramped screens, like I mentioned before, limit the number of tools that we use. It helps to reduce the toggling among the screens, allows the support personnel to see the relationships among data, how one particular sensor data is negatively impacting another application or another sensor from performing it to its optimum. And also it lowers probabilities of incorrect decisions. So when you keep on toggling among screens, sometimes you might end up with the wrong decision and carry it out on the client device, which could be detrimental. Communication related inefficiencies, how can we address them? So if you can have a tool which is able to automatically execute remedial steps, that will help in reduce the difficulty in coordinating a response among different chat groups, because since working from home, we would need to tend to ask a lot of people, hey, what do we do with this? What is the proper solution? Maybe that fellow is not there in his seat at the moment, so the entire solution gets delayed. So tools related inefficiencies. So like I mentioned earlier, you need to continuously keep an eye on the monitors. This becomes very impracticable at home when you are working from home amidst distractions that you have. So if you can have a tool which like an omni-channel alert notification tool, where you have multiple channels of notifying of alerts being notified. So alert comes onto your mobile phone and you take initial remedial steps, and those can be carried out later on your desktop once you're available at your seat. So seamless transition of notification among devices is very important at these times. I think I covered this. Yes. So what is actually required, if you like, think of a flow diagram. It's basically, so you have the solution automatically raising tickets onto the support portal, and then this is the level 0, L0, what Heshan mentioned previously. So if it's possible to have a system where it can execute these remedial steps automatically without the intervention of individuals, then it greatly reduces the number of issues that appear onto your support team. So so what we could do is like how virus detectors work. You have an issue dictionary involved. So it's where all the support team, the high level technical support like L3, L4, they detail out if these sort of issues appear, this is what these are the rectification steps that needs to be carried out. So by auto executing these remedial steps, you can cut off a lot of these repetitive issues that tend to come over. So, and you escalate the issue only if the auto remedial steps have failed, let's say to L2 or L3, and then L2 or L3, like they actually execute the necessary remedial steps on the environment, and also then simultaneously update the issue dictionary so that it can cater for these issues if it appears again. So eventually this leads to an increased level of client satisfaction. Since you would not notice in the previous example which I used, we had a lot of client interaction, but here the client was not interacted at all. So, so we can share insights from these episodes to the client. Hey, we did encounter a situation like this, and we noticed something like this, and this is what we have executed. Maybe you need to start thinking about upgrading your system, or looking into adding more resources to your network, because we are seeing problems like this appearing. So, so disruptions are generally inevitable since remote working from home is something of the norm at the moment. So the efficiency of your working from home staff solely depends on the tools that they are using. So as we have seen over the last few days, how IoT subsystems are deployed, the challenges faced by the teams, and how to efficiently handle these issues, all boils down to having the right IoT tool. So the moment you have several tools involved, the efficiency of your team goes down. It's difficult difficult to identify a problem, correlate what is the how an issue is affecting several subsystems. It becomes more and more difficult when the complexity of your solution increases. So with that, I end this this session with a quote from a director from Reddit, where he says that remote working is going to be the future of all work. Thanks all. Have a great day.
All right. Okay. Thank you, Ishrat, and thank you, Heshan, for the third episode of this series today. I think we had quite a few questions, and behind the scenes, Asanka answered most of the questions. Asanka, is there any questions which you want Heshan or Ishrat to take live? There's one question pending, Heshan, if you can just have a look at.
Sure. So basically, MQTT protocol is used for many IoT use cases. This is actually something that was introduced for IoT initially. Of course, there are there are protocols that are more efficient in certain use cases today, like such as CoAP, and protocols like BSON, which can be used in certain situations. But MQTT is used for many IoT use cases. So basically, at the heart of it, it is a publish-subscribe protocol, which means that a sensor can publish information, and so many other sensors, so many other actuators, dashboards, IoT, like edge nodes or even backends can receive this information by subscribing to it. And these MQTT brokers are highly scalable. They are built in with fault tolerance mechanisms as well, called bridging or mirroring. So as a result of that, I mean, usually it is a question of what kind of use cases don't use MQTT, which is rare. But of course, there are situations where you opt for protocols like CoAP as well. But that being said, I need to highlight a protocol called LWM2M, which is short for lightweight machine-to-machine communication, which is not in broad usage at the moment, but it actually solves a lot of problems in the sense, if you use MQTT, you need to actually remodel aspects like how you're going to push a command to an endpoint. Like from application to application, you need to remodel that messaging. Though the broker handles the scalability and the efficiency of the protocol exists, at an application level, you have quite a lot of modeling to do. Like how do you deliver a firmware update? How do you send a command? How do you send a configuration? How do you know if the configuration was successful? So LWM2M, or lightweight machine-to-machine communication protocol, was introduced to both have the scalability and the lightweight nature to it, and at the same time have these basic structures such as configurations, commands, firmware update delivery built into the protocol itself. So as a developer, you don't need to redesign a protocol for your application to handle those aspects.
So thanks, Heshan. Now, before I actually come back to Heshan and Ishrat, I have one more message to the audience today. Like, okay, now you've been participating in this series from Monday, Wednesday, and Friday today. You've been a part of this session right throughout. Now, if you have a question or a remark or a compliment or whatever that you want to say to our panel, you can use listen very carefully, don't raise hand up until I explain this very carefully. You can use the raise hand and I will make you to speak. Then you can come on live and you can actually speak to the audience and give your compliments, talk to the panel and ask a question directly. So who wants to grab the opportunity? Just use the raise hand option and I will grant you the feature or the facility to speak. Anyone? Looks like the audience is a little shy. Because I saw a couple of hands going up during the session, but I was expecting that like people who would want to talk to the panel directly. All right, looks like they are a little shy to come on screen and speak. Okay, now Heshan, like if I give you like just 2 minutes or maybe 3 minutes, just to wrap up everything, like from day one to what we discussed during the second episode and the third episode, just to recap, how would you go about it?
Sure. So basically, first thing is for us to understand what the Internet of Things is, right? A lot of people tend to confuse when you say Internet of Things, it's a smart home, it's a smart city, etc. But if you really understand it for what it is actually a state of technology that allows us to sense and make sense and then act on the real world, right? When you look at it from that sense, for what it actually is, and even just leave out some of these very technical, it says, you know, it's a situation where machine-to-machine communication is enabled at scale. But that doesn't really give you an insight in terms of thinking of how you can really use the Internet of Things, right? So that's why we brought up that definition. It is a state of technology that allows us to sense, make sense, and act on the real world. That's number one. Then, I mean, we discussed, of course, how you can do this, about the smaller computers out there, how they're energy efficient, how network protocols and coverage has increased and made these use cases possible. We spoke about how big data engineering techniques are allowing us to process data in a timely manner, how cloud computing is reducing the burden of purchasing this computing real estate where you can pay as you go, and how artificial intelligence is becoming very commoditized, where you don't need scientists or PhDs to actually implement an artificial intelligence solution today. It's actually pretty well laid out, where you find even schoolgoers actually coming up with their own AI implementations, which is really cool. And of course, you've got the IoT platforms that help you bootstrap. Then we spoke about what actually makes the Internet of Things useful. So the first part was to excite you and hopefully get you to think, so that once you understand what the IoT is, then what it really is, then you can apply this to your real world and come up with brilliant product ideas, project ideas, which can really put Sri Lanka on the map there, right? So then next, when I showed about the glorious side of it, Asanka came and gave you a reality check where, you know, a lot of people just go behind the hype and fail. So the idea is, don't apply IoT for the sake of applying IoT. This is not for the hobbyists or the hackers who, when I say hackers, I'm talking about programmers who are trying to come up with solutions quickly, right? Not the black hat security guys. I'm not talking about them. So the guys who want to really try things out, they should just try things out. For you to learn, you don't necessarily have to think of all the business value. But at the end of the day, when you plan to apply, when you want to productize it or bring it into your business, first think from the business point of view. What problem am I trying to solve? Then look at, hey, is IoT the real solution for it? When I deploy this solution, don't get caught to the hype of the service provider or your IoT partner. Make sure that they cover your end-to-end needs. Talk to them about how you're going to maintain this. Do you have the technology for it? Do you have the expertise for it? Cross-question that, make sure that you fully understand what your world is going to be like even after you do your implementation. Because even the business value that you get out of it can get set off if your maintenance is not taken care of. Right? And then on the second day, we discussed, okay, we took a business pitch, a conceptual pitch of IoT. Then we took a fairly simple example and looked at what actually is involved internally in taking a small system and making it IoT enabled. We spoke about the hardware layers, how they connect. We spoke about, we just gave you snippets of USB, Ethernet, Bluetooth to show you there's no rocket science in that, right? And then we spoke about the fog computing layer. And I saw some very interesting questions coming in, and I think we should tackle one of those as well to correct the understanding of it. So we spoke about the fog computing layer. So let me take that here as well. So you talk about the cameras, right? And other sensors which are able to do somewhat high-level decision-making and processing. So does that mean that fog computing will not be needed or eliminate the need for it? Short answer is no. I actually provided a similar answer in the previous question a person answered. So remember, the fog computing layer takes care of the uh, store and forward. Let's say you don't have network connectivity, you still need fog computing to be able to store and forward that information. Secondly, let's say you have a smart camera which can do a certain amount of decision making, but what if you need to combine input from multiple cameras to make a decision? Single camera can't do that. You need a fog computing there. And also remember that this is about sensor fusion. Camera is one type of a sensor. You might combine that with a motion sensor. You might combine that with a temperature sensor. You might combine that with the proximity sensor to realize certain use cases. So you don't always, even if you have 5G or whatever that is, you might want to respond very rapidly. And in those kind of situations where you can't rely on the network, or you can't actually assume that the network will always be resilient and stay there, you're going to need fog computing. Apart from that, you're going to need fog computing to reduce load on your servers. These sensors, especially, there's this term coming in as it's about not big data, but big analog data. So analog data is telemetry data, which is at massive rates, right? Frequencies are very high. And if you think you're going to push all of that data unnecessarily to the cloud, you're going to have a massive farm of servers. You're going to be spending hundreds of thousands of dollars maintaining those servers. And no matter how fast those servers are, unless you do like an extremely unnecessarily complex implementation, you're not going to get real-time responses that you might need to respond at the fog layer. So as a result of that, no, none of these things will necessarily eliminate it. Certain use cases, I'm not saying it's not possible, but still there will always be scope depending on the requirement, right? And so we spoke about the fog layer, then we spoke about a typical IoT architecture. And from there on, we moved on to Ishrat's aspect of what does it take to actually keep an IoT alive. We spoke about certain aspects like heterogeneity and scale and volume. So we spoke about the needs of aspects like self-healing. We spoke about how you need to have one dashboard and not many dashboards, and typically one system. And Ishrat even took on examples of how we manage certain RFID, e-signs, and kiosk combined situation within a retail environment, right? And then we finally came to day 3, where this was all about, okay, so you've been used to supporting technology from the comfort of your office with all the fancy infrastructure, excellent bandwidth, multiple displays, high definition ones, UHD, 4K type resolution displays. Now you're stuck at home with your LCD or laptop display and maybe one more monitor. How do you manage multiple displays or multiple systems and dashboards? How do you manage your remote desktop bandwidth? How do you manage that, the time it takes to click on one button and wait for it to load and then click on the other buttons, So how our support technology is not tailored towards these work from home scenarios, and how they need to be tailored through mechanisms like we talked about L0 support, where before humans, let machines make the initial call. Only if it can't be done, trickle it down to humans. Why? There are at least, well, it's not correct to say at least, we've seen situations where there's L1 and L2 support. It's based on definition. So we spoke about the standard model where 4 levels of support, L1, L2, L3, L4. We said L1 is the least technical. They handle customer queries based on scripts. And then you have the L4, which is extremely technical, which are the implementers and the engineers. And while the technical capability is reduced down the line, the cost of maintaining those resources actually increase. And how your goal has to be to reduce the number of resources at L3, L2, L4, and L1 in a descending order, so that your cost of operation can be maintained, because you don't want to have large amounts of L4 guys responding to large amounts of support tickets. So in a nutshell, this has been the summary of all 3 days.
All right. Thank you very much, Heshan. And for one last time, can we have like Asankar and Isru also on stream for us to actually wind up? Guys, this is the team who was behind the scenes supporting Israt and Heshan to deliver the course during the day 2 and day 3. Of course, Asankar did a part of the presentation on the day 1. And with this, actually, we have come to the end of this 3-episode series of the online short course on Internet of Things. And thank you very much, Eshan, Ishrat, Asanka, and Isru for joining with Apidem to deliver this course. And I thank the entire team at Zone 24/7 for coming forward to facilitate this program on behalf of Apidem. And all of those who participated in this program, Monday, Wednesday, and Friday, thank you very much for connecting with us for 3 days during the same week. And as I promised earlier, you'll be contacted by the Apidem staff. Some people from our team will be in touch with you during the course of next week, and they'll let you know about the details about the virtual certificate we are going to offer for participating in this program. All right, so thanks everyone. Thank you very much for joining in for this program, and until we meet again in a program like this, goodbye and have a wonderful evening and enjoy your weekend. See you.
Okay. Thanks for everyone. Take care. Bye.
Take care.